This problem is about a bear on a floating ice. So here's the picture you see here. So they give you the density of the ice, which is 917, which is less than density of water. And they also give you the density of seawater, which is 1025, which is more than the density of water. So we have assuming polar bear climbs onto a piece of floating ice, which has a volume. They give you the volume. The question is, what is the weight of the heaviest bear that the ice can support without sinking completely beneath the water? All right. So what we need to do is to start with a free body diagram. So remember that if you look at this, we have the bear, we have the ice, but just for the free body diagram, what I'm going to do is I'm going to look at the bear and the ice piece together. All right. So my objective interest is going to be the bear and the ice together. So if you look at that, the free body diagram will look like this. The basically the weight of the ice. All right. So I'm going to say mass of the ice times gravity for that, and then the weight of the bear will coming down, mass of the bear times g upon 8, and then the upward force. So the question is, what do you think is balancing both of them? Well, the force that balances the bear and the ice is the buoyant force. So I'm going to show it, which is going upward. I will call that FB. That's the buoyant force, is the one that goes up. Okay. So basically, if you balance the forces, what we have is the buoyant force is equal to mass of the ice times g plus mass of the bear times g. Okay. Now, if I keep my everything in kilogram, all right, I'm going to just keep it in kilogram. So if I want to keep everything in kilogram, then I can drop the g here. I don't need to use g. So FB in kilogram will be equal to mass of the ice plus mass of the bear. Okay. So if you want the maximum, they want the heaviest bear. All right. So they want the heaviest one. So we want the highest one for this. So you will get the heaviest bear to support the ice will given by the highest buoyant force. Okay. Now the buoyant force is going to be large when the whole um, ice is underwater. All right. So we are going to use the whole volume to find the buoyant force. Now you know the buoyant force is basically the volume of the ice times technically the volume of the ice times gravity, but we are not going to use gravity here as kilogram anyway. So you can figure out the buoyant force simply. Okay, so the question is, how do we find this buoyant force? All right. Okay, so buoyant force is equal to the basically the mass of displaced water. Mass of displaced seawater. Okay, so we can find that out simply by we know the volume of the ice, right? And then if you multiply by the density, we get the mass. All right, so that mass is density times volume. So I'm going to use the density of seawater, which is 1025, and the volume of the ice, I'm going to assume that the whole ice is underwater, so that'll be 5.2. And if you calculate that, you should get let's see how much is that. Okay, so 1025 times 5.2 gives me 5330 30 kilogram. All right, so this is the maximum buoyant force you can expect when the whole ice is underwater. Okay, all right, so I know that. And then the question is, then I'm looking for the mass of the bear here. So if I put this for the buoyant force, right, and I need to know the mass of the ice. Okay, now how do I find the mass of the ice? Well, I use the density of the ice multiplied by volume. All right, and the density of the ice is 917 and the volume of the ice is 5.2. So if you do this, 917 times 5.2 gives you 4768 kilogram. All right. Okay, so now if I go back and use this equation, so let me just change the color here. So I'm going to use this back here. So the buoyant force, we figured it out, 5330. All right. So that's the buoyant force. So I can put it for that, 5330 equals mass of the ice, we figured it out, 4768 plus mass of the bear. Okay, so from this we can find the mass of the bear by subtracting 4768 from 5330. So 5330 minus 4768 will give you the mass of the heaviest bear. And if you do that, that'll be 562 kilogram. Okay, so that's the way you do that. So we have used Archimedes' principle to find the maximum buoyant force. Okay, and then using the densities, we found the mass of the ice, and then we can solve for it. So this is the weight of the maximum, sorry, the maximum weight of a bear which can the ice can support.